For this link sheet, which is the hiker, I'm going to throw this up here so I can keep an eye on my time. It says it's a little bit different than the last one because the information that we're given is a little bit different. It says Thomas went on a hiking expedition and took a GPS unit with him. When he got home, he decided to download the data and was only able to get 2 of the coordinate points for his trip. The points are given in the form of time in minutes and then elevation in feet. So this is telling us automatically what our x and y values are. So our x is going to be time, and it's in minutes, and our y value is going to be the elevation in feet. And it goes on to tell us that the 2 points that he is able to retrieve are these 2 points. So he has, at 24 minutes, he was 1,032 feet up. And at 84 minutes, he's at 498 feet. Okay? Using only this information, he also wants to know the following time, where he was at 10 minutes, at 40 minutes, at 47 minutes, 65, and 125 minutes, and we'll need to fill in the rest of this data. Should complete the following link. Okay, should the slope be positive or negative? So as the value of x is increasing, right? So if we have our graph, as the value of x increases, so as I go this way, the value of, or obviously as I go this way, the value of x increases. What is happening to the value of y? So as the value of x increases, the value of y is decreasing. That's going to give us a negative slope. Okay, so I cannot figure out any of this rest of this information until I have come up with the equation. Okay, because to be able to figure out where he is at 10 minutes, I need to be able to put the 10 in for x and then figure out what y is. So I have to come up with the equation. Well, I have 2 points, right? And I know that my slope is the change in y over the change in x. So what I'm going to do is I'm going to figure out my change in x and I'm going to figure out my change in y, and I'll be able to substitute the numbers here and figure out my slope is. For the time, if I'm going to figure out how many minutes it takes to go from 24 to 84, what I'm going to do is I am going to take the 84 and I'm going to subtract the 24. So I'm going to take the 84 and I'm going to subtract the 24. So 84 minus 24 is 60 minutes. That means my change in x is 60. But if I said 84 minus 24, then I need to do the same direction right here. So when I figure out what this change is, I'm going to need to say 498 minus 1,032. And that's going to give us a negative 534. Okay, so negative 534. So when I simplify this, I'm going to end up with a negative number, and we did say that we were going to have a negative slope. So negative 534 divided by 60 is negative 8.9. Now, this is a scenario, it has specific units. So the change in y, what does the change in y stand for? It stands for the elevation, or feet. What does the change in x stand for? It stands for time, which is in minutes. So that means Thomas, for every 1 minute, his elevation decreases by 8.9 feet. Now we need to figure out the y-intercept. I cannot say at 0 minutes where his elevation was. because he didn't start down here at 0 minutes and he's climbing uphill. Instead, he is somewhere up here and he's going down here. Downhill. So I have to figure out what his initial elevation was. So for that, we're going to go ahead and choose the y equals mx plus b. Well, actually, what you could do is, since you have the slope and a point, you could start with the point slope form. So I could say y minus, and I'll just use this one, 1032 equals negative 8.9 times the quantity x minus 24. And then I can leave it like this. Of course, that doesn't give me the exact y-intercept, but to find the y-intercept, I can just take this and turn it into slope-intercept form. So y minus 1032 equals negative 8.9x. A negative times a negative is going to be a positive. So 8.9 times 24, 213.6. And then now I add to isolate the y. And I will end up with y equals negative 8.9x plus 1,245.6. So there's my y-intercept. And in fact, I actually, by finding the y-intercept like this, I went ahead and wrote my explicit equation that I'm going to use. So then with that information, I can substitute all of these different x values in, and I can find out what the elevation was. Okay, incidentally, right now I also know that at 0 minutes, I'm at an initial height of 1,245.6 feet. All right, so I am going to substitute x in, rather the 10 in for x, etc., and I will be right back after I'm done with that. Okay, and there are the different values that I got. Okay, now I'm going to go ahead and make my graph. Okay, I know that my x is elevation in feet, so I will go ahead and label that. I know that my x is time in minutes. Give yourself a little space under here to write. Okay, my graph is Thomas's elevation per minute. I know that for my time, I'm going to start at 0 minutes, and I can go all the way up to 125, right? Because I have 0 as my low and 125 as my high. And I have 20 of the little grid lines, right? 1, 2, 3, 4, all the way up to 20. So I'm going to start at 0. And I need to at least have enough to get to 125. So I'm going to take 125 and divide by 20. That gives me 6.25. So what I'm going to do is I'm going to go ahead and count by, I'll count by 5s, and I just won't get all the way up to 125. And that'll be all right. So I have 0, 5, 10. I'm going to fill these in. I'll be right back. Okay, so I filled those in, and now I need to also do my counting or my unit numbers for the y. So my y numbers, my smallest y number is 133. That's at 125. So I didn't go up to 125, so I'm not going to include this one. So my second lowest number is 498. Okay, so I need to be able to go from 12,045 to 498. But I do need to be careful because I am starting at 0. So do I want to start at 0 for the feet and elevation, or do I want to start closer to 498? It's really your choice. I'm going to go ahead and start at 0. So that means I'm going to take 1245 0.6 and divide it by 20 because that's how many lines I have. And it gives me 62.28. So what I'm going to do is I'm going to go ahead and make each one of these worth I'll just go ahead and make them worth 62.28. I'll make them worth 100. So this would be 100, and then, you know, I don't write all the numbers in. So 100, 200, 300, 400. I'll be right back. I'm going to fill mine in. Now I'm going to look at my data table, and I'm going to fill in each of my plots. Okay, and when I finish that, that is what my graph looks like. So finally, I need to go through and answer the questions. Now don't forget, when you go through and answer the questions, you must start with the explicit equation. So the explicit equation that we came up with was y equals negative 8.9x plus 1,245.6. Okay, it says in part A, when was he at an elevation of 418 feet? We know that the elevation is the y value. Round your time to the nearest minute. They're asking us to find x. So we're going to start with y equals negative 8.9x plus 1,245.6. I'm going to substitute y for 418. And I'm going to finish solving. Okay, so I went through and I solved for x, and when I did that, I got 92.988. It is time, so I went ahead and rounded that up to 93 minutes. It says, where was Thomas 36 minutes into the trip? So 36 minutes, they're giving us x, and it says where. In other words, the elevation. They want us to find y. So I start with my explicit equation. I substitute 36 minutes in for the x, and I solve for y. Ugh, I'm out of space. Sorry guys, I know that's so squishy. Y equals negative 8.9 times 36 plus my y-intercept, which was 1,245.6. I'm going to do that calculation. Okay, when I finish that calculation, I end up with y equals 925.2, and don't forget, this is a scenario and now we need units. So 925.2 feet. Then it says, what was Thomas's starting elevation? Well, his starting elevation was at 0 minutes. Starting elevation. All right, so we're supposed to, find y when x is equal to 0. Well, we already have that. That's the y-intercept. Whenever x is equal to 0, we're talking about the y-intercept. So we already figured out that his initial elevation was 1,245.6, and it's a scenario, so we need to have units, feet.